We have seen that vibration of the source is necessary for the production of sound. What is required for the propagation of sound? When an object begins to vibrate, the layer of air in contact with it also begins to vibrate with the same frequency as that of the object. As a result, the layer of air next to that layer also begins to vibrate. Thus, sound travels away from the source. Could this happen if there was no air? The substance through which sound travels is called the medium. Air is one medium through which sound travels. Let us try an experiment. Take a 25 to 30 meter length of cotton string. Fix each end of the string to the center of the base of an empty paper cup through holes made in their bases. This is your telephone. Now, tell your friend to hold one cup to his ear. Pull the string straight and taut. Hold the other cup to your mouth and speak into it softly. He will easily hear what you say. How does this happen? The paper cups vibrate when you speak. These vibrations travel through the string to the other cup, and that cup too vibrates. That is how your friend can hear you. Besides, the cup is cone-shaped, and this helps to amplify the sound. If you wish to hear better than this, use a wet string. Your voice will be heard more clearly. If the string breaks and you knot it together, the telephone does not work anymore because the vibrations are not propagated. This tells us that the string is also a medium through which sound travels. Also, sound needs the string or some other medium for its propagation. To verify that a medium is necessary for the propagation of sound, you can easily do this experiment yourself. Take a round-bottomed flask with some water in it. Take a 2-holed rubber stopper. Pass a glass rod or wire through one hole. Tie a bell to one end of the rod and fit the stopper to the flask with the bell inside the flask. Now, pass a glass tube through the other hole. Attach a piece of rubber tubing to its outer end. Fit it with a clamp and close it. Shake the flask. You will clearly hear the bells ringing. Now, open the clamp and heat the flask till the water boils and steam comes out through the rubber tube. Stop heating the flask and clamp the rubber tube shut. Allow the flask to cool. You could pour cold water onto it to cool it quickly. The steam inside cools and condenses. Now shake the flask again. You cannot hear the ringing anymore. Why? After the steam condenses, there is no medium left inside to carry the sound out of the flask. Now open the clamp and shake the flask. You will hear the bell quite clearly because the outside air has now entered the flask and it acts as a medium again. Thus, it is clear that a medium is necessary for the propagation of sound. Hence, we can note down the points to remember that 1. A medium is necessary for the propagation of sound. 2. Sound can be propagated through solid, liquid, as well as gaseous mediums. 3. Sound travels faster through liquid than through gaseous medium and fastest through a solid medium. Let us try another experiment. Ask your friend to knock on a table with his finger or a pencil so softly that you can barely hear the knocking. Now, rest your ear on the table. You will find that you can hear the knocking at the other end quite clearly. You can also perceive that the sound comes through the table. Try another experiment with your friend. Blow a balloon and hold it close to your ear. Listen to the sound you make as you scratch the balloon. Now, let the air out of the balloon and fill it with water. Scratch on it again. What difference do you notice in the sound? We see that sound is heard more clearly through water than through air. Children, that is why your friend could hear the sound more clearly if wet string is used in the telephone prepared out of paper cups. Like light, sound also reflects. Let us learn about the reflection of sound. Have you ever been to a hill station? You are almost certain to find an echo point there. If you shout standing on top of a mountain, the sound is reflected back from the mountain opposite you and you hear your own shout again after some time. This is called an echo. This tells us that sound is reflected from a flat surface and travels back in the direction from which it came. Try this. Take a long, about 10 cm wide wooden plank. Place it across a table, as shown in the figure, with its width perpendicular to the surface of the table. On one side of this piece of wood, lay a plastic tube of 2 cm diameter on the table at an angle of about 30 degrees with the wood. At the end of the tube, place a watch that makes a ticking sound. Place a similar plastic tube on the other side of the piece of wood. At the point at which the two tubes meet, keep a flat, smooth piece of wood at right angles to the long plank. Now, put your ear to the outer end of the second tube and listen for the ticking of the clock. Vary the angle this tube makes with the long piece of wood till you hear the ticking clearly. Note the measure of this angle. Repeat this experiment, changing the angle of the first tube every time. What do you see? When the two plastic tubes make equal angles with the piece of wood, the ticking can be heard most clearly. It means that 1. Sound is reflected from a flat surface. 2. When sound is reflected, the direction of the incident sound and the direction of reflection make the same angle with the normal. Children, do you know what is the speed of sound? You have seen that the speed of sound is greater in solids than in liquids or gases. At a temperature of 20 degrees Celsius, the speed of sound in air is about 340 meters per second. It increases as the temperature increases. We cannot compare the speed of sound with that of light. Light travels at about 3 multiplied by 10 raised to 8 meter per second. That is, light travels at a speed of about 10 raised to 6 times or 1,000,000 times that of sound. You will now understand why, when there is thunder and lightning, we see the flash of lightning instantaneously, but we hear the sound, that is thunder, much later. How much later? We know the speed at which the light and sound travels. Light travels faster than sound, so we see the flash of lightning before we hear the sound of thunder. In the previous chapter, we have seen when the sound is produced in sitar. Let us now see how sound is produced in different musical instruments. You must have attended a music concert. What are the instruments played by those accompanying a singer? String instruments have several strings. The strings are plucked to produce sounds. Each string has a different frequency. The desired frequency can be obtained by adjusting the tension in a string. In percussion instruments like drums, a stretched membrane is struck to produce sound. The tension in the membrane can be varied. Hence, the desired frequency can be obtained. In wind instruments, sound is produced by blowing into them to cause vibrations in a column of air. By placing the fingers on different holes, the length of the vibrating column of air can be varied. Thus, sounds of the desired frequency can be obtained. Let us learn about noise and music. Let us try this experiment. Place some pebbles in a tin can and shake the can. You hear sounds. However, there is no regularity in this sound. Hence, we perceive it as a harsh sound. What is the difference between the sounds of traffic, crowds, etc., and the notes of a flute when played by an accomplished artist? The notes from a flute are in a particular rhythm. Their frequencies are in harmony. The sound has a specific regularity. Hence, the music has a melodious tune. In comparison, noise follows no rules. Frequencies change constantly. Loudness changes irregularly. When everyone in the class speaks together, nothing can be understood. There is only noise. This is the difference between music and noise. Noise pollution. The problem of noise pollution is becoming more and more serious every day. The intensity of the sounds we hear keeps increasing because of the growth in industry, number of vehicles, their speed, increasing population, etc. If the intensity of sound crosses a certain limit, it can cause deafness, psychological disorders, and some physical disorders too. This is called noise pollution. That is why we see boards saying silence or silence zone near hospitals, schools, residential buildings, etc. Several social organizations are engaged in working to reduce noise pollution.